Hello viewers, in today's lecture we are going to take up some conceptual problems on three-dimensional geometry. So here we'll take up problems involving plane and line, right? So the first problem is we have to find the equation of a plane passing through the point -1, 3, 2 and perpendicular to each of the planes. So here we have to find the equation of a plane which passes through this point. Now we know that the equation of a plane passing through a point, say this is x1, y1 and z1, is given by a times x minus x1 plus b times y minus y1 plus c times z minus z1 is equal to 0. So this is the equation of the plane passing through a single point x1, y1 and z1, and a, b, c are the drs of the plane P. So let us draw this plane like this, right? So this is the plane P. Now here x1, y1, z1 is -1, 3, 2. So substituting here we get x, here we have +1, then we have b, y minus 3 and plus c, z minus 2 equal to 0, right? So here the drs of the normal to this plane P are given by A, B and C, right? Okay, now this plane P is given to be perpendicular to each of these two planes, right? So if we draw the perpendicular planes like this, suppose this is the plane P1, this is plane P1, and let us say this plane is P2, right? Now this plane is perpendicular to P1 and P2, and let us draw the plane P2, and suppose this is the plane P2, right? Now we see that this plane P is perpendicular to these two planes. So P is perpendicular to P1 and P is also perpendicular to P2. Now the plane P is perpendicular to P2, so therefore the normal vector to this plane P is also perpendicular to the normal vector to plane P1, right? So vector n is perpendicular to n1 vector. Similarly, vector n is perpendicular to the normal vector to plane P2, right? So when two planes are perpendicular, whenever two planes are perpendicular, their normals are also perpendicular, and when the two planes are parallel, their normals are also parallel. So now the drs of vector n, here this is the normal, so the vector n has the drs a, b, c, and the drs of the normal, drs of vector n1 are the coefficients of x, y and z respectively, right? And the drs of vector n2 are 3, 3 and 1, right? Here we have 1. Now here vector n is perpendicular to vector n1, So we know that if two vectors are perpendicular and their drs are a1 b1 c1 and a2 b2 c2, then we have the condition a1 a2 plus b1 b2 plus c1 c2 is equal to 0. So here vector n is perpendicular to vector n1. So from here we get the equation a times 1 plus b times 2 plus c times 3 equal to 0, and vector n is perpendicular to vector n2. So from here we get the equation a times 3 plus b times 3 plus c times 1 is equal to 0. Now from here we can write these two equations as we can write these equations as a plus 2b plus 3c equal to 0, and from here we have 3a plus 3b plus c equal to 0. Now here we have three variables but two equations. So here what we will do, we will try to eliminate one variable from these two equations. So what we will do, we will multiply this equation by 3, right? So we have 3a, here we have 3a plus 6b plus 9c is equal to 0, right? What we have from here, we have two equations in three variables a, b and c, and in order to solve these two equations in a, b and c, we will try to eliminate one variable, any one variable. So here we are eliminating variable a. So we multiplied this equation by 3. So 3a, 6b, 3 3s are 9c equal to 0. Now we will solve, or we will subtract these two equations, right? So if we subtract these two equations, 3a get cancelled, so we have minus 3b, and from here we have minus 8c is equal to 0. Now we can write minus 3b equal to 8c. Clear? Okay, now here we can introduce a parameter, let us say k, right? So minus 3b equal to 8c equal to k. So we can write the value of b as minus 3b equal to k. So b is minus k by 3. From here 8c is equal to k, so c can be equal to k by 8, right? Now if we substitute these values of b and c in equation, say this is equation 2, then we can find the value of a. So let us substitute these two values here. So we have a and plus 2b means it is minus 2k by 3. Then we have 3c, that is 3k by 8 equal to 0. Now a is equal to 2k by 3 minus 3k by 8, and if we solve these two fractions, we get 16k minus 9k divided by 24, that is equal to 9k, sorry, it is 7k divided by 24. So the value of a is 7k divided by 24. Now the values of a is 7k by 24, the value of b is minus k by 3, and c is k by 8, right? Now substituting these three values in equation 1. So we get the equation of the plane as, so here the value of A is 7k by 24 times x plus 1, and here the value of B is minus k by 3 times y minus 3, and the value of C is k by 8 times z minus 2 is equal to 0. Now multiplying throughout by 24, we get 7k times x plus 1 minus 8k times y minus 3, and then we have plus 3 times 3k times z minus 2 is equal to 0. Again dividing by k, because k is here not equal to 0, so we have 7 times x plus 1 minus 8 times y minus 3 plus 3 times z minus 2 is equal to 0. Now this is 7x plus 7 minus 8y plus 24 plus 3z minus 6 equal to 0, and we have 7x minus 8y plus 3z, and 7 plus 24 is 31, 31 minus 6 is 25, so plus 25 is equal to 0. So this is the equation of the plane which passes through minus 1, 3, 2 and perpendicular to these two planes, right? Now let us take this problem. Here find the coordinates of the point where the line through this point 5, 1, 6, and let this point be A, and 3, 4, 1, let this point be B, crosses the YZ plane. Now here this is the YZ plane, and let this line AB crosses this YZ plane at this point P. Now we know that any point which lies on YZ plane has its x coordinate 0. So the coordinates of this point P, where this line meets this plane, is 0, y, z, right? Now we have to find the coordinates of this point P. Now let us write the equation of a line AB, right? Now we know that a line which passes through 2 points is given by x minus x1 divided by x2 minus x1. This is y minus y1, and this is y2 minus y1, and this is z minus z1, and this is z2 minus z1. So this is the equation of this line AB. Now here we will substitute the value of these 2 points. Here this is x1, y1, z1, this is x2, y2, z2. So the equation becomes x minus 5 divided by 3 minus 5, y minus 1 divided by 4 minus 1, and z minus z1, that is 6, and z2 minus z1, so 1 minus 6, right? So this can be written as x minus 5 divided by minus 2, y minus 1 by 3, and z minus 6 by minus 5, right? So this is the Cartesian equation of this line AB. Now let us take the parameter lambda. Now the coordinates of any general point, that is general point on line AB, is given by x minus 5 by minus 2 is equal to lambda, y minus 1 by 3 equal to lambda, z minus 6 by minus 5 is equal to lambda, right? So here the direction ratios of the line are minus 2, 3 and minus 5. Now here we can find x equal to minus 2 lambda plus 5, and y is 3 lambda plus 1, and z is minus 5 lambda plus 6, right? Now here we are given that this line AB crosses this plane at this point P where the x coordinate is 0. So here we will substitute x equal to 0, and if we solve this equation we get minus 2 lambda is equal to minus 5, so lambda is 5 by 2. Now substituting this value of lambda here, we get 3 into 5 by 2 plus 1, that is equal to 2 ones are 2 and 15 plus 2, 17 by 2. And here if we substitute the value of lambda here, we have 2 6 are 12 minus 25 plus 12 divided by 2, this is minus 13 by 2. So therefore the coordinates of this point P are 0, and the y coordinate is 17 by 2, and the x coordinate is minus 13 by 2, right? So this is how we solve this problem. Now let us consider this problem. Find the vector equation of the line passing through 1, 2, 3 and parallel to the planes P1 and P2. So here the given line is L, and the equation of this line is given by x minus x1 over a, y minus y1 over b, z minus z1 over c, right? Now x1, y1, z1 is this point, and L is x minus 1 by a, y minus 2 by b, and z minus 3 by c, right? Now here a, b, c are the drs of this line, right? Now this line is parallel to these two planes, so it means the normal to this plane is say n1, and normal to this plane is say n2, right? This is the normal to this plane. Now this line L is parallel to the plane P1. This implies that L is perpendicular to the normal vector n1. Similarly, L is parallel to P2. This implies that L is perpendicular to vector n2. Now the drs of L are a, b, c, and the drs of this vector n1 can be obtained from here, and the drs are 1, 1, minus 1 and 2, right? Here we have 1, here we have minus 1, and here we have 2. So 1, minus 1 and 2 are the drs of normal vector n1, and the drs of vector n2 are 3, 1 and 1, right? Here we have 1, here also we have 1, right? Now L is perpendicular to vector n1, so therefore we have a times 1 plus b times minus 1 plus c times 2 is equal to 0. L is perpendicular to vector n2, so we have a times 3, b times 1, c times 1 equal to 0. Now if we simplify these two equations, we get a minus b plus 2c is equal to 0, and here we have 3a plus b plus c is equal to 0. Now here we have three variables and two equations. Now in order to solve these two equations, what we will do, we will eliminate any one variable. So here we see that the variable c is can be easily eliminated here. So if we add these two equations, minus b and b get cancelled, we have 4a, here we have 1, so 3 plus 1 4a, and here also we have 1, so this is 3c equal to 0. Now we can write from here 4a equal to minus 3c. Now here we can introduce a parameter, say k, right? So 4a is equal to k implies 4a is equal to k implies a is equal to k by 4, and minus 3a equal to k, it is c minus 3c equal to k implies c is equal to minus k by 3. Now we will solve this equation for b by substituting the values of a and c here, right? So if we substitute here the value of a, we get k by 4, here we have minus b, then we have plus 2c, it means minus 2k by 3 equal to 0, right? So b can be written as k by 4 minus 2k by 3, and this is 3k minus 8k divided by 12, and this is minus 5k by 12, right? Now we have obtained the values of a, b and c in terms of k, where k is not equal to 0, right? Now we will substitute these values here, right? So we have x minus 1 divided by a is k by 4, and here we have y minus 2 divided by b is minus 5k by 12, and this is z minus 3 divided by c is minus k by 3, right? Now multiplying throughout by k, we have x minus 1 divided by 1 by 4, this is y minus 2 minus 5 by 12, and we have z minus 3 divided by minus 1 by 3, right? Now we can write this equation in the form 4 times x minus 1 by 1, this is 12 times y minus 2 divided by minus 5, and this is 3 times z minus 3 divided by minus 1, right? Now dividing throughout by 12, we have x minus 1 by 3, and here 12 get cancelled, so we have y minus 2 by minus 5, and here we have z minus 3 divided by minus 4, right? So here we have divided this equation by 12, right? Now here the drs are 3, minus 5 and minus 4, and if we further multiply this whole equation by minus 1, then we have x minus 1 by minus 3, y minus 2 by 5 and z minus 3 by 4, right? So we have multiplied this equation by minus 1, right? Here the direction ratios of this line are 3, minus 5 and minus 4, and here we have also applied the concept that two parallel lines have the direction ratios proportional, right? So here multiplying by minus 1 we have minus 3, here we have plus 5, here also we have plus 4. So this is the vector equation of this line, and if we convert this equation into vector form, this is the Cartesian equation, the vector equation can be converted into this equation is converted into this form. So we have I cap plus 2j cap plus 3k cap, and then we have lambda times the vector b is minus 3i cap plus 5j cap plus 4k cap, right? So this is the vector equation of this line, and here this point represents the point through which the line passes.